So section 11.3 is arcs and central angles. So a couple definitions first. What's a minor arc? All the points on the circle that lie in an angle less than 180 degrees. And we name it with 2 points, meaning 2 letters. So minor, think less than 180. The measure of a minor arc is the measure of the central angle containing it. And this is how we would write it. Measure of arc AB equals 60 degrees. So you can see over here, here's our minor arc AB, and 60 degrees here would be the central angle. So then therefore the measure of arc AB equals 60 degrees. Next, we have a major arc. A major arc are all the points that do not lie on a minor arc. And we name it with 3 points, meaning 3 letters. And how do we find the measure of a major arc? We take 360 minus the measure of the matching minor arc. So for example, this major, so if we are looking at minor arc AB in the red, then the major arc would be ADB. Notice I used 1, 2, 3 letters to name that major arc. Otherwise, if you just use the letters A and B, you don't know if I'm talking about the minor or the major arc. So you have to use 3 letters for the major arc, because that shows me that I need to go around this way. So this is major arc ADB. So if we take 360 degrees and subtract out the red 60 degrees from the minor arc here, then that equals 300 degrees. So the measure of this major arc is 300 degrees. So you can see if you add up the 300 plus the 60, that totals 360 degrees, and there are 360 degrees in a circle. There are more blanks here, but we're gonna come back to that later in the notes. So don't worry about those blanks for now in your notes. So name the red arc and identify the type of arc. So right here is the red arc. So we have DF, so that's arc DF. Is it major or minor for the type? Well, it's 40 degrees, so it's less than 180, so it's considered a minor arc. And what's the measure? The measure is the measure of the central angle, which you can see is 40 degrees here. Now looking at the next one, here's the red part. You probably can't see this in your notes, so just you can see where it's red on the video here. So this is the arc we're talking about. We need to use 3 letters to name it because it's a major arc. It's a major arc because it's more than 180 degrees. And since it's a major arc, we need to use these 3 letters. And again, just make sure you go in the right order, LMN, or you could say NML for the arc name. What is its measure? Well, the minor arc here, LN, is 110 degrees. So we need to do 360 minus 110 to give me 250 degrees for the measure of our major arc. So this is 250 degrees. 250 plus 110 is 360, and there are 360 degrees in a circle. So we're going to talk about the arc addition postulate. The measure of an arc formed by 2 adjacent, remember adjacent means next to, 2 adjacent arcs is the sum of the measures of the 2 arcs. So we've looked at a lot of addition postulates in the past year, and so this is very similar. So the measure of arc ACB, we just have to add the red and the blue together. So the measure of arc ACB is the here, I'll use the right colors, is the measure of arc AC plus the measure of arc CB. Notice I put M for measure there. So if I add the red, the measure of the red plus the measure of the blue, I get the measure of the green, which is arc ACB. And that's the arc addition postulate. So the next example says, find the measure of arc GEF. So let's find where arc GEF is. GEF. All right, we'll have to add all three of those arcs together then. So 40 degrees plus 80 degrees plus 110 degrees gives me the measure of arc GEF, which is 230 degrees. So find the measure in circle T. We want the measure of QS. So Q to S. So that's from here to here. So I need to add this 40 degrees plus this 60 degrees. So 40 plus 60 is 100 degrees. So the measure of arc QS is 100 degrees. So now, on the front of your notes, these are the blanks that are under the measure of a major arc. So you can flip to the front to fill out these blanks here. Two circles are congruent. Remember, congruent means equal or the same. They're congruent if they have the same radius. And then also, two arcs are congruent if they are on congruent circles and have the same measure. Okay, so circles are congruent if they have the same radius, and two arcs are congruent if they are on congruent circles and have the same measure. So for example, and I know there's another blank there that says arc length. We'll get to that after these two examples. So here, 45 degrees and 45 degrees, they're arcs that are on the same circle, and they are the same measure. And since they're on the same circle and on the same measure, and have the same measure, then they are congruent. So yes, arc AB is congruent to arc DC. Now in this next example, we're looking at two arcs that are not on the same circle. So they do have the same measure. They're both 65 degrees as the picture indicates, but they're not on the same circle though. So therefore they're not congruent. So we can say arc XY is not congruent to arc ZW because they're on different circles. And you can see that they look like different sizes too, right? Even though the central angle for both of them is 65 degrees. So same measure, but they're not on the same circle, therefore they're not congruent. Okay, so here's the last blank on the front of your page. So if you flip to the front of your notes, arc length is a portion of the circumference of a circle. So how do we find the arc length? In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So what do I mean by that? The measure of arc AB, the length, not the measure, the arc length of AB is the measure of arc AB, which we talked about on the front page of the notes, divided by 360. So pretty much we just want to know what portion of the circle is it. right? So we take the measure, divide it by the total, which is 360 degrees, and then we multiply it by the circumference, which is 2 pi r. So it says find the length of the red arc. So what we need to do, I'm just going to set up the formula. It's the measure of arc AB, which we learned on the front page, divided by 360 times 2 pi r. That's how we find the arc length. Okay, that's the formula. So the measure of arc AB is 50 degrees. We divide that by 360 and multiply it by 2 times pi times r. So what I would do first is plug this in your calculator and then multiply it by 2 times pi times 5. And when we do that, we get 4.36 centimeters for the arc length of the red arc. Okay. Here, same thing. So the measure of arc AB, because AB is in red, divided by 360 times 2 pi r. So the measure of that red arc is 120 degrees. Remember, we're finding arc length times 2 times pi times r, and our radius is 2. Plug that in your calculator. I would first plug in 120 divided by 360, take that decimal and multiply it by 2 times pi times 2, and you'll get 4.19 inches. And 2 more examples. So the red here is the arc CD, so the measure of arc CD divided by 360 times 2 times pi times r. So what is the measure of arc CD? It's 50 degrees divided by 360 times 2 times pi times r. Again, plug in your calculator and we get 6.11 centimeters. Last but not least, the red arc here is 180 degrees. So this is actually considered a major arc. So we need 3 letters to name it. So EFD covers the red, divided by 360 plus 2 times pi times r. So see, this is 180, so that means the red is also 180. So we have 180 divided by 360, which is half, times 2 times pi times my radius of 4. And you plug that in your calculator and you get 12.57 feet. All right, I'm going to look at the homework with you, help you get it started. All right, so the first section says name the blue minor arc and find its measure. So remember, minor arcs are named with 2 letters. So this is arc PQ, and find its measure. The measure of arc PQ is 135 degrees. Okay. And then let's look at number 4. So name the blue major arc. So remember, you need 3 letters. So B, D, A. So arc BDA. And then we want to find the measure of arc BDA. Well, if this here is 75 degrees, then we need to do 360 minus 75 degrees, which is 285 degrees. So the measure of arc BDA is 285 degrees. So remember, you need to do 360 minus the minor arc. Determine whether the arc is minor, major, or a semicircle. So I didn't talk about semicircle in the notes. Semicircle is just half. Okay, so like P, if, let me find one. Arc TUP, that's a semicircle. Okay, I'll tell you all of the semicircles. Number 9 is as well. So PQT, PQT, so that's also a semicircle. And then the other ones are just major or minor. If it's less than 180, it's minor. If it's greater than 180, it's major. If it is 180, then it's a semicircle, which we already covered both of those. Find the measure of angle ACB. So measure of angle ACB, I want to know this angle measure. That's 165 degrees because that's what the measure of the arc is. All right, so not too bad. And then the next, this is probably the hardest section of the homework. KN and JL are diameters, find the measure. So I'm going to help get you guys started on this one. If this is a diameter, that means there's 180 degrees here. So 55 plus this missing part, we'll just call it X, plus 60 equals 180 degrees. So that's 115 plus X equals 180. That means X is 65 degrees. So now that you know that part, that's going to help you answer some more questions. To find the other two angles, I'm going to show you, we have to look at vertical angles here. So since I can draw the X, this is a 60-degree angle. And then here, let's see, I can't draw the X. Let's draw the X here. So we need to know the measure here. Well, that's going to be 55 plus 65, which is 115. So this is 115 degrees. Okay, so now you can pause this video and now you have all the angle measures that will help you answer number 18 to 27. Are the blue arcs congruent? This is, I'm going to go back to our notes. This is where you want to check two things. Are they on the same circle and do they have the same measure? If yes, then they're congruent. If no, not on the same circle, then no, they're not congruent. So for example, these are not on the same circle and the radii are different, right? 5 and 6. So the circles are not the same. So this is no. These are on the same circle, and if you look, these are vertical angles, which means these do have to be the same. So that's yes. These are on different circles, but the radius measure is the same. So therefore, it's technically the same circle. And they both have the same measure. So this is yes, they are congruent. And then again, these are vertical angles, but this one's kind of tricky. F is not in the center of the circle. So therefore, look at the measures of these. Do they look congruent? No, because they're not. They're not congruent. F is not in the center. And then just this last page, find the length of arc AB. So this is where you use the formula, right? The measure of arc AB over 360, because we want to know what portion of the circle it is, times 2 pi r. So we would plug in 45 here, and we would plug in 3 for r here. And that's what you're going to do for the last 6 problems. As always, let me know if you need any help.